In this lesson, we will again be looking at solving systems of equations, except in this lesson, we're going to be solving systems of equations using matrices. So in addition to the other methods that you previously learned, like substitution, elimination, you can also use Cramer's rule to solve a system of equations. I will let you determine which method is the most useful for you to solving systems of equations. All right, so given the following 2x2 system, if we're going to use matrices to solve this 2x2 system, the first thing we want to do is find the determinant of the coefficients that have variables in front of them. We want to find the determinant, so we want to exclude the constants on the right side of the equation, and we will find the determinant of the remaining coefficients. So the remaining coefficients after we cross out the constants are A1, B1, A2, and B2. That will be our denominator determinant. Next, we want to find the determinant for the x. The x determinant, again, is following a similar process. We want to cross out the x's, the column that has the x's, and then we want to find the determinant of the remaining values, the remaining coefficients and constants. Notice there's a negative in front of this determinant. Make sure that you remember to include the negative whenever you're finding the x determinant. And then you'll notice that the values, the elements of that determinant are B1, C1, B2, and C2, the remaining numbers after we exclude the x's. To find the determinant for the y's, or the y determinant, we're going to exclude the y's, cross out the y's, and then find the determinant of the remaining values. So inside the determinant, we should have A1, C1, A2, and C2. Notice there is no negative in front of the y determinant. So once we actually have all three of those determinants, the x value of our solution, the x coordinate of our solution, is going to be the determinant for the x, or the x determinant, divided by the denominator determinant. And then we will find our y value by dividing the y determinant, or dy, by the denominator determinant. Here's what that looks like. We have the following system. We're going to first find the denominator determinant by excluding the constants. Once we cross out the column with our constants, we should have 3, -5, -2, and 1. The value of that determinant is -7. When we find the x determinant, we cross out the x column, and the remaining values should be -5, -22, 1, and -4. The value of that determinant is -42. Again, don't forget the negative in front of the x determinant. And then the y determinant, we cross out the y column and then write down the remaining determinant, the remaining values, which should be 3, -22, -2, and -4. The value of that determinant is -56. So now the x coordinate of our solution is going to be the x determinant, -42, divided by the denominator determinant, -7. So the x coordinate of our solution is 6. The y value can be found by dividing the y determinant, which is -56, by the denominator determinant, negative 7. When we do that, we get 8 for a solution of 6, 8. And then lastly, we want to take a look at a 3 by 3 matrix. And those can also be solved using matrices and determinants. So again, just like the last example, we're going to cross out the column that has our constants to find the denominator determinant. The denominator determinant, the x determinant is what is left when we cross out the x column. Should be 6, 2, 4, negative 1, 6, negative 13, negative 1, negative 4, and negative 7. The y determinant has a negative in front of it. For 3 by 3 matrices or third order matrices, you have a negative in front of the y determinant. For 2 by 2 systems, you have a negative. Whenever you're using Cramer's rule, you have a negative in front of the x determinant. For 3 by 3s, you have a negative in front of the y determinant. And then we get the z determinant by crossing out that z column. The remaining values are negative 2, 6, 4, 2, negative 1, negative 13, negative 4, negative 1, and negative 7. All right, so when we calculate the denominator determinant, the first term is negative 2, the top left corner, times the, once we cross out the row, the other numbers that are in the same row and column as negative 2, we're left with negative 1, 6, negative 1, negative 4. And so we find the determinant of that 2 by 2 determinant. We get negative 1 times negative 4 is 4, minus negative 1 times 6, which is 6. And then we go to the next row, next element in the first row for the denominator determinant. And we have minus 6, which is that next element in the first row. Cross out everything else that's in the same row and column as the 6. And we'll have 2, 6, negative 4, and negative 4. When we find the determinant of that 2 by 2, we get 2 times negative 4, which is negative 8. Negative 4 times 6, which is positive 24. And then the last term is the last element in the first row, that 2. Cross out all the elements in the same row and column as the 2. And the remaining elements would be 2, negative 1, negative 4, and negative 1. Find the determinant for that 2 by 2. 2 times negative 1 is negative 2. Minus negative 4 times negative 1 is positive 4. When we simplify that expression, we get negative 128. Similarly, we find the x determinant by following those same steps. 6 times the minor determinant minus 2 times the minor determinant, and then 4 times its minor determinant. Once we simplify that expression, we get negative 512. Carrying over the value that we calculated for the denominator determinant and the x determinant, we now need to find the y determinant. And again, we follow the same steps. Start with the first element in the first row, and then negative 2. Cross out all the elements that are in the same row and column as the negative 2 and find the determinant of the remaining values. Go on to the next element in the first row, which is the 2. We're going to subtract 2 times the remaining determinant after we cross out the numbers in the row and column as the 2. We'll be left with 2, 13, negative 4, negative 7. So we find the determinant for those 4 values. And then we go to the last element in the first row, which is that 4. Cross out all the other elements in the same row and column as the 4 and find the determinant of those remaining values. 2 times -4 is -8 minus -4 times 6, which is -24. Once we simplify, we get -384 for the y determinant. And lastly, the z determinant, following the exact same steps. Start with the first element in the first row, -2. Cross out all the elements in the same row and column as the -2 and find the determinant. Go to the next element, and we always are subtracting for 3 by 3s. We always are subtracting that middle term whenever we're finding the determinant. So for the 6, which is the second element in that first row, we're going to cross out all the other elements in the same row and column. That will leave us with 2, -13, -4, -7. Find the determinant. And then the last element in the first row is the 4. Cross out all the other elements in the same row and column as the 4. We're left with 2, -1, -4, -1. Find the determinant. And once we simplify that expression, we get 384. All right, so now we can find the x coordinate of our solution by dividing the x determinant by the denominator determinant. It's 4. The y coordinate of our solution can be found by dividing the y determinant by the denominator determinant. That's 3. And the z coordinate of our solution can be found by dividing the z determinant by the denominator determinant. That's -3. For a solution of 4, 3, -3. You can also refer back to the systems, the 2 by 2 and the 3 by 3 systems of equation notes, and you'll see that we got the same answers, just using different method. For these, we got the same answer, but we used Cramer's rule for this lesson.